Start.
Okay, so we are Team 12, and our project is called The First Contact. My name's Savannah Hutchins.
Jonghyun. I'm Kurt.
And Mary.
Excellent. So a little bit of backstory. In 1969, Neil Armstrong visited the moon for the first time. We think we know the whole story, but do we really? Do we know what he encountered, who he encountered? So basically, First Contact is kind of the depiction of what we think actually happened. So our target market, Purdue students, faculty, alumni, and collectors. This is Purdue related. Neil Armstrong's very close to Purdue. Space enthusiasts, and then children interested in machine design. Our toy has a lot of different mechanical mechanisms, so this would be really good for kids that are interested in that kind of thing.
So a few of the little components that we have in here. So looking at this, the most obvious one you see is Neil Armstrong, who is the smaller astronaut sticking up out of the moon. So Neil will actually be following a cam as he goes across. And then we also have 3 different sets of aliens that will be moving up, down on a 4-bar linkage. And then finally, there is a flag that will pop out when Neil hits the other side of the moon. So to go a bit more into Neil, so Neil follows a cam, and he's actually printed with a slider, with an insert that will be moving along a slider. So he actually just follows the curvature of the moon, and then the cam has waves in it, so he actually looks like he's bobbing up and down as he goes across. So this is powered by a servo. We have to turn on a switch to actually power everything, and then by pushing a button, the user can send Neil across, and then as Neil's going across, there are actually sensors. So Kurt will talk a bit more about the aliens, but then when he gets all the way to the side, the sensor for the flag will sense that he's there and will pop up the flag. So, and then this is a video of the actual cam as he goes across.
Okay, so it's for alien mechanism. As Mary mentioned, I used crank slider mechanism, and then the bottom of the slider is powered by servo, so it's just moving up and down. And then there's a regulating vertical movement component so that it only moves up and down and like not fall apart in other direction that's not desired. So there's a demo here, video. So that's the normal up and down motion, and then the second one is hiding motion. So notice it goes further down into the moon. So we 3D printed all the parts that we need except for the servo that we used, and we have IR sensors, and then the IR sensor detects where the Neil is, and then as the Neil passes in front of him, he kind of hides into the rock debris that we created here because they're shy.
Okay, so the flag mechanism is relatively simple. The part itself is 3D printed, and then it's connected to a servo motor. And when IR sensor detects Neil Armstrong at the endpoint, it'll trigger the servo motor, and then the flag will pop up. And as long as Neil stays at the endpoint, the flag will just stay there. And then when you push the button and Neil goes back to its initial position, the flag will go back in. And here's the demo of the flag.
So prototyping and fabrication. So the majority of our stuff we put into Creo. We did some 3D modeling of it so that we could easily 3D print it. We did do laser cutting for the board that we have here. So it's just a circular base, so there isn't anything protruding out of the sides. We used the SLA printing and very quickly used up all of our limit to actually print the 2 halves of our moon that you see here. We used real rocks that we accidentally spray painted outside to build up a little barrier around the aliens that it looks like they're hiding as they go down. And then we did spray paint everything at the end. And then these are just some of the purchased parts that we used. So we had the ESP32 microcontrollers. We have all the IR sensors that we talked about that will actually control when the aliens hide and when the flag pops out. Servo motors, the wooden board, and magnets to hold the moon together.
So for our budget, we stayed in budget. Most of it was spent on the sensors and the Arduino and the microcontroller. So that was where the majority of our cost was, but we did end up staying in budget. And then we do have some videos here. We have improved since some of these, so these kind of show our trial and error process, but it gives you a good idea of how the mechanisms actually move. So we'll start with those. So you can see here we had some issues, but we've troubleshot those issues, and we're in a better place now. So we can actually show the live demo here. So you actually push a button, and then Neil will start his journey across the moon. And then the flag should pop out. And then you push the button and he travels across. So our most recent issue has really been the sensors. We've had some sensor failures, so we're working on replacing those and fixing some of the wiring, and hopefully we'll have that sorted out by the Toy Fair on Monday. Any questions?
Thank you.
Oh, I have a question.
Oh.
What was the biggest challenge you guys faced?
Well, there were multiple. Yes. I was the black hole on this crew, so I made a lot of failures. I guess to say. So yeah, while I was drilling the holes for the vertical limiting components, I accidentally cracked the whole moon up. So it fell apart, but thanks to the super glue that we had, we held it through all together. And so on the CAD modeling, I just have it as a vertical component so that it's normal to the bottom surface. But when I was drilling through, it was actually normal to the surface of the moon, which was not normal to the bottom surface. So I had to file a lot of moon down to fit the vertical components in. And after that, it was not, the alien wasn't really moving vertical, it was angled in a bit. So fitting the servo motor in a position so that it has desired movement, that was another challenge. So, but we managed to address all of that for now. Yeah, any other questions?